DeepSeek's bold move, 300 new jobs created in semiconductor sector to fuel AI chip innovation. Date, February 14, 2025. Location, Hangzhou, Zhejiang Province, China. Introduction. In a significant stride for the semiconductor and artificial intelligence AI sectors, DeepSeek, a burgeoning Chinese tech company, has announced the creation of 300 new jobs. This initiative aims to enhance its capabilities in AI chip innovation, positioning DeepSeek at the forefront of the global tech landscape. This announcement aligns with broader efforts in Zhejiang Province to establish itself as a leading hub for advanced technology, especially in AI. Key developments and timeline. 1. Launch of R1 model. In January 2025, DeepSeek unveiled its R1 large language model LLM, an open-source AI tool that has garnered attention for its competitive edge against established players like OpenAI. Priced significantly lower than its counterparts, the R1 model is seen as a potential game-changer in the AI market. 2. U.S. market reaction. Following the R1 model's launch, U.S. President Donald Trump described the development as a wake-up call for American tech firms, leading to a notable decline in the stock price of semiconductor giant Nvidia. The share price dropped from $142 to $128.99, highlighting the immediate impact of DeepSeek's entry into the competitive landscape. 3. Zhejiang Province's ambitions. Local officials in Zhejiang Province, where DeepSeek is based, are actively working to bolster the region's computing capacity, targeting a combined performance of 100 EFLOPS by the end of 2025. This ambitious goal reflects the province's commitment to fostering a vibrant tech ecosystem. Implications of DeepSeek's innovations. DeepSeek's launch of the R1 model signifies a pivotal moment in the AI and semiconductor industries, showcasing the potential for cost-effective innovation. The training costs for the R1 model are reported to be around $5 million, a stark contrast to the billions spent by competitors like OpenAI for similar technologies. The ability to develop high-performance AI models at a fraction of the cost has profound implications for the competitive dynamics within the tech sector. Reports suggest that DeepSeek's R1 model is 20 to 50 times cheaper than OpenAI's offerings, raising questions about the sustainability of traditional pricing models in the AI industry. Government support and strategic goals. The success of DeepSeek is bolstered by strong support from the Zhejiang provincial government. Officials have articulated a vision for the province to become a leading force in AI technology, with a commitment to providing favorable policies and infrastructure development for tech firms. This backing is critical for nurturing innovative startups like DeepSeek and fostering an environment conducive to advanced technology. Zhejiang's historical cooperation between the government and tech firms has established a robust ecosystem. The presence of major players like Alibaba has attracted a talent pool of tech graduates, contributing to a dynamic landscape for innovation. Market response and global context. The emergence of DeepSeek has shifted investor sentiment regarding Chinese tech innovation. Analysts note that DeepSeek's success could motivate further investment in China's private tech sector, which has long been a top priority for the Chinese government. The tech landscape is witnessing a shift in focus from macroeconomic challenges to the competitive capabilities of domestic firms. However, the geopolitical context cannot be ignored. The U.S. government's stringent export controls on advanced technology, particularly in AI and semiconductors, have inadvertently spurred innovation within China. As restrictions tighten, Chinese firms like DeepSeek are finding ways to develop cutting-edge technologies using limited resources. Controversies and challenges. DeepSeek's rapid ascent has not been without controversy. The company faces scrutiny over its claims regarding GPU utilization and training efficiency. Critics argue that the lack of transparency could undermine confidence in the technology and its claimed cost advantages. This skepticism is compounded by broader concerns about the implications for U.S. equity markets, as DeepSeek's low-cost model challenges the traditional financial structures supporting AI development. Despite these challenges, industry experts agree that DeepSeek's innovations represent a significant step forward for the AI sector. The introduction of cost-effective models could democratize access to AI technologies, fostering greater competition and innovation across the globe. Conclusion: DeepSeek's announcement of 300 new jobs in the semiconductor sector is a bold move that underscores its commitment to AI chip innovation. As the company positions itself as a formidable player in the global tech arena, the developments in Zhejiang Province reflect a strategic pivot towards self-reliance and innovation. The implications of DeepSeek's advancements extend beyond the company's immediate success, potentially reshaping the competitive dynamics between Chinese and U.S. tech firms. As the world watches, DeepSeek's journey will undoubtedly influence the future of AI and semiconductor technologies on a global scale. The rise of DeepSeek as a significant player in the semiconductor and AI sectors has revealed several counterintuitive insights about innovation cost structures and geopolitical dynamics. 1. Cost efficiency versus market dominance. One of the most striking aspects of DeepSeek's emergence is the perception that high-quality AI technology inherently requires high investment. Traditionally, companies like OpenAI have operated under the assumption that significant financial resources are essential to develop competitive AI models. However, DeepSeek has demonstrated that a model can be developed with just $5 million in training costs, a stark contrast to the billions spent by companies like OpenAI. This challenges the conventional wisdom that higher costs correlate with superior technology, highlighting that innovation can arise from cost-effective methodologies rather than sheer financial muscle. 2. Government support in innovation. DeepSeek's success is often attributed to its independent private sector foundation, which runs counter to the narrative that state-owned enterprises or heavily subsidized firms drive technological advancements in China. While government support in Zhejiang Province is evident, the fact that DeepSeek emerged from a hedge fund with no direct government subsidies underscores the potential of private sector efficiency in driving innovation. This challenges the stereotype of Chinese tech development being predominantly state-driven. 3. Geopolitical tensions fueling competition. The U.S. government's restrictions on technology exports to China were intended to stifle Chinese innovation. Ironically, these measures have spurred companies like DeepSeek to innovate more rapidly and creatively. This suggests that external pressures rather than merely inhibiting growth can catalyze a more aggressive and innovative response from firms facing such challenges. For open source versus proprietary models, the trend towards proprietary models in AI has been dominant, with companies like OpenAI moving away from open source frameworks. DeepSeek's commitment to an open-source model is counterintuitive in a landscape where proprietary technology is often seen as the path to competitive advantage. This shift not only democratizes access to powerful AI tools but could also accelerate innovation across the sector, contradicting the belief that closed systems are more advantageous. 5. Market reactions and perceived threats. The immediate reaction of U.S. markets to DeepSeek's launch, particularly the decline in Nvidia's stock price, reflects a broader unease regarding competition from Chinese firms. This highlights a counterintuitive aspect of market behavior. The presence of a more cost-effective competitor can provoke fear and uncertainty among established players, indicating that market dominance is less about being the best and more about being perceived as invulnerable. 6. Innovation amidst uncertainty. The narrative surrounding Chinese tech firms often emphasizes stability and state support. However, DeepSeek's rise amid geopolitical uncertainties and export restrictions illustrates how companies can thrive in environments characterized by unpredictability. This counters the notion that only stable conditions foster innovation. Instead, the challenge can lead to creative solutions and rapid advancements. 7. Re-evaluation of resource utilization. Skepticism regarding DeepSeek's claims about GPU utilization speaks to a broader conversation in the tech industry about efficiency versus availability. The Jevons paradox, where improved efficiency leads to increased overall consumption, is a critical aspect of this discussion. As DeepSeek pushes for cost-effective AI training, the potential for increased demand could paradoxically lead to resource scarcity, challenging the initial premise that lower costs would naturally lead to reduced consumption. These insights underline a fundamental shift in how we understand the dynamics of innovation, competition, and market behavior within the context of AI and semiconductor technology. DeepSeek's approach not only disrupts existing paradigms but also invites a re-evaluation of what constitutes success in the tech industry. The report on DeepSeek's recent developments in the semiconductor sector and its ambitious job creation initiatives presents several important insights that many might overlook. While the report highlights the immediate implications of job creation, cost efficiencies, and geopolitical tensions, certain underlying themes and details merit further attention due to their potential long-term significance. 1. Cost efficiency as a disruptive force. DeepSeek's R1 model is reported to be 20 to 50 times cheaper than OpenAI's equivalent models. This stark difference in cost efficiency is not merely a financial anomaly, it signifies a broader trend in the AI industry where cost structures are being redefined. The ability of DeepSeek to produce high-quality AI models at a fraction of the cost of established competitors could lead to a democratization of AI technology. Significance: the implications here extend beyond immediate market competition. If such cost efficiencies become the norm rather than the exception, it could lead to an explosion of new applications, startups, and innovations in the AI space. This could disrupt traditional business models and reshape the tech landscape, enabling smaller players and startups to compete effectively with established giants. The shift towards more affordable AI capabilities can catalyze advancements in sectors historically constrained by high costs such as healthcare, education, and small business operations. 2. Government support and ecosystem development. The role of the Zhejiang provincial government in fostering an environment conducive to tech innovation is crucial. The commitment to achieving a computing capacity of 100 EFLOPS underscores the strategic vision of local authorities to position Zhejiang as a leading tech hub. Significance: this highlights a trend where regional governments actively participate in nurturing tech ecosystems, which is often overlooked in discussions about technology development. The successful collaboration between government and private sector entities can lead to a robust innovation pipeline. Other regions, particularly in the US and Europe, might need to re-evaluate their strategies for fostering innovation and consider more direct support mechanisms for local tech companies. This collaborative model may become a blueprint for future tech hubs globally. 3. Geopolitical implications of tech competition. The response of U.S. markets to DeepSeek's entry into the AI sector, particularly the decline in Nvidia's stock, reflects the anxiety surrounding U.S.-China tech competition. The comment from Donald Trump labeling DeepSeek's launch a wake-up call encapsulates a growing recognition that Chinese firms are not simply imitators but are becoming formidable competitors. Significance: the geopolitical ramifications of this tech competition extend beyond market fluctuations. As countries ramp up their investments in domestic tech capabilities, we may witness a bifurcation of global technology ecosystems. This could lead to a fragmented landscape where technologies developed in one region may not be interoperable with those from another, complicating international collaboration. The need for nations to strategize around technological self-sufficiency may become a key driver of innovation policies worldwide. 4. The open source movement in AI. DeepSeek's decision to make its R1 model open source is a noteworthy element that could reshape the competitive dynamics within the industry. Open source initiatives have historically spurred rapid innovation by allowing broader participation in technological development. Significance: the embrace of open source by a competitive Chinese firm can signal a shift in how AI technologies are developed and shared. If DeepSeek successfully fosters a collaborative ecosystem around its models, it may encourage other companies to follow suit, potentially leading to a renaissance of open innovation in AI. This could counterbalance the trend towards proprietary systems seen in major U.S. firms and may create a new standard for transparency and accessibility in AI development. 5. Long-term market dynamics and sustainability. The report discusses how the low training costs of DeepSeek's AI models challenge the established norms of the AI market. However, it also raises questions about the sustainability of such a model. Critics point out that while initial costs may be low, increased demand could drive up prices in the long run. Significance: this introduces a critical dialogue about the sustainability of business models that rely on ultra-low costs to gain market share. If demand for AI capabilities escalates due to lower entry barriers, companies will need to find ways to balance cost efficiency with profitability. The potential for a Jevons paradox, where increased efficiency leads to higher overall resource consumption, suggests that businesses and policymakers must consider not just immediate cost advantages but also the long-term implications for resource allocation, environmental impact, and market stability. Conclusion: DeepSeek's strategic initiatives to create jobs and disrupt the semiconductor sector represent a pivotal moment in the ongoing evolution of the global tech landscape. However, the nuances of cost efficiencies, government collaboration, geopolitical ramifications, the open-source paradigm, and market sustainability present a complex picture that goes beyond surface-level interpretations. As stakeholders navigate this rapidly changing environment, recognizing and addressing these often overlooked elements will be crucial in shaping the future of technology innovation and competition. 1. Cost efficiency and disruption in AI development. DeepSeek's launch of the R1 large language model has significantly altered the competitive landscape in AI by offering a solution that is 20 to 50 times cheaper than counterparts like OpenAI's models. This cost efficiency not only democratizes access to advanced AI technologies but also challenges the existing pricing structures established by major U.S. firms. The implications of this cost disruption extend beyond immediate market dynamics, raising questions about the sustainability and viability of expensive AI development models in the face of emerging competitors who can leverage lower costs to attract users and developers. 2. Government support and regional innovation ecosystems. The proactive role of the Zhejiang provincial government in fostering a tech-friendly environment is crucial to DeepSeek's rise. With ambitions to position itself as a global hub for advanced technologies, Zhejiang's policies provide essential infrastructure and support for startups, creating a fertile ground for innovation. This local government backing highlights the importance of regional ecosystems in nurturing tech companies and suggests that effective collaboration between government and private sectors can lead to significant technological advancements and a shift in competitive advantages. 3. Geopolitical dynamics and market reactions. The geopolitical context surrounding DeepSeek's emergence is significant, especially in light of U.S. export controls on semiconductor technologies. This backdrop has fueled a narrative of technological competition between the U.S. and China, with DeepSeek's success serving as a potential catalyst for increased scrutiny and regulatory responses from U.S. authorities. The immediate market reaction, including the decline of Nvidia's stock following DeepSeek's announcement, illustrates the interconnectedness of tech markets and how developments in one region can reverberate across the globe, impacting investor sentiment and corporate strategies. For open-source innovation and industry standards, DeepSeek's decision to adopt an open-source model for its AI technologies represents a pivotal shift in the AI development paradigm. By allowing others to modify and commercialize its models, DeepSeek fosters a collaborative environment that can spur rapid innovation and create new standards in the industry. This approach challenges the trend towards proprietary technologies and highlights the potential for open-source solutions to drive competition and accessibility in AI, prompting existing players to reassess their strategies in response to this new model of collaboration and transparency. 1. The rise of Japan's semiconductor industry in the 1980s. In the late 1970s and early 1980s, Japan emerged as a dominant force in the semiconductor industry, challenging U.S. supremacy. Companies like NEC, Toshiba, and Hitachi developed advanced manufacturing processes and technologies that allowed them to produce high-quality chips at lower costs. The Japanese government supported this growth through favorable policies and investment in R&D. This led to significant market share loss for U.S. companies, prompting a response from the U.S. government, which enacted trade measures to protect its semiconductor industry. Similar to the recent geopolitical tensions around AI technology and semiconductors. 2. The U.S. response to Sputnik and the space race. The launch of the Soviet satellite Sputnik in 1957 marked the beginning of a fierce rivalry in space technology between the U.S. and the USSR. The U.S. government recognized the need to bolster its own technological capabilities, leading to increased investments in education research and development through initiatives like the National Defense Education Act. This response mirrored the strategic pivot seen in the tech industry today, where nations are investing heavily to maintain technological superiority in the face of emerging competitors like China's DeepSeek. 3. The development of the South Korean electronics industry. In the 1990s, South Korea underwent a technological transformation, becoming a global leader in electronics and semiconductors. The government implemented policies to foster innovation and support the growth of companies like Samsung and LG. These firms invested heavily in R&D and advanced manufacturing, allowing them to compete effectively on the world stage. This historical case parallels the current ambitions of Chinese firms like DeepSeek, which seek to disrupt established markets through innovation and government support, highlighting the strategic importance of technology in national economic development. Future outlook, predictions for DeepSeek and the semiconductor sector. In light of DeepSeek's recent advancements and its ambition to create 300 new jobs in the semiconductor sector, the future landscape of AI chip innovation appears poised for significant transformations. Here are some predictions regarding the implications of DeepSeek's initiatives, the semiconductor sector, and the broader tech ecosystem. 1. Increased competition in AI development. DeepSeek's or one large language model, which has demonstrated capabilities comparable to leading models like OpenAI's at a fraction of the cost, signals the beginning of a new era of competition in AI. As more companies, particularly from China, emerge with similar cost-efficient models, we may see an acceleration in AI research and development. This competition will likely drive innovations, making AI tools more accessible to smaller firms and startups, ultimately democratizing AI development. 2. Shift in semiconductor supply chains. DeepSeek's move underscores the necessity for robust semiconductor supply chains that can support the burgeoning AI demand. The creation of 300 new jobs in this sector indicates a growing emphasis on local manufacturing capabilities in China. This trend is expected to lead to a significant shift in global semiconductor supply chains as countries prioritize self-sufficiency in critical technologies, reducing reliance on U.S. suppliers like Nvidia. 3. Geopolitical tensions and technological decoupling. As competition intensifies, geopolitical tensions between the U.S. and China are likely to escalate. The U.S. government's export restrictions on semiconductor technology may further drive Chinese companies to innovate independently, fostering a more insular tech ecosystem in China. This decoupling could lead to a bifurcated global tech landscape where two parallel systems, one led by the U.S. and the other by China, emerge, each with its own standards and technologies. 4. Acceleration of AI democratization. DeepSeek's open-source model not only challenges proprietary systems but also promotes collaborative development. This shift towards open-source AI will likely encourage more developers and researchers to participate in AI innovation, resulting in a rapid proliferation of new applications and technologies. The potential for customization and improvement in AI tools will open new avenues for businesses, particularly in emerging markets. 5. Emerging trends in AI cost efficiency. DeepSeek's ability to deliver high-quality AI solutions at significantly lower costs than its competitors will likely prompt a broader industry re-evaluation of cost structures. Companies may start to prioritize cost efficiency in their AI strategies, leading to innovations in model training and deployment that require fewer resources. This focus on efficiency could alter the investment landscape, shifting funds from traditional high-cost AI solutions to more adaptive and cost-effective models. 6. Government support and policy changes. The proactive stance of the Zhejiang provincial government in supporting AI and semiconductor initiatives serves as a model for other regions. As more local governments recognize the strategic importance of technology sectors, we may see an increase in policy support funding and incentives aimed at fostering innovation. This trend will likely lead to the emergence of additional tech hubs in China and around the world. 7. Rise of new tech hubs. With DeepSeek's success, Zhejiang Province could emerge as a new tech powerhouse similar to Silicon Valley. Other regions may replicate this model, leading to the rise of new innovation centers globally. These tech hubs will likely focus not only on AI but also on complementary technologies such as quantum computing and blockchain, creating a more diverse tech ecosystem. 8. Increased investment in AI and semiconductors. As the competition heats up, investment in AI and semiconductor technologies will likely surge. Both public and private sectors will allocate more resources to research and development, aiming to capture market share in the rapidly growing AI landscape. This influx of capital could spur breakthroughs in semiconductor manufacturing processes, leading to more powerful chips that can support advanced AI applications. 9. Potential for regulatory scrutiny. As companies like DeepSeek gain prominence, they will likely face increased regulatory scrutiny, particularly concerning data privacy and security. Governments may implement stricter guidelines to ensure that AI technologies are developed and deployed responsibly. This regulatory landscape could shape the trajectory of AI innovation as companies navigate compliance while striving for rapid growth. 10. Long-term impact on global tech dynamics. In the long run, DeepSeek's advancements may redefine the competitive dynamics in the global tech ecosystem. The combination of cost-effective AI solutions and supportive governmental policies in China could lead to a significant shift in market power. As Chinese companies continue to innovate and disrupt established norms, the global tech landscape may witness a realignment, where emerging markets play a more prominent role in shaping future technological advancements. Conclusion. DeepSeek's bold move to create jobs and innovate within the semiconductor sector is indicative of broader trends that could reshape the AI landscape. As competition intensifies and geopolitical dynamics evolve, the future of AI and semiconductor technologies will be characterized by increased innovation, collaboration, and a push towards self-sufficiency. The implications of these developments will extend beyond national borders, influencing global tech dynamics for years to come.